once we have our hypotheses, the next step would be to collect and summarize the sample data. And for us, that specifically, we want to compute what's called the point estimate, which is a sample value that estimates the parameter of the hypotheses. So again, the parameter of the hypotheses, that's goes with what we're claiming. The point estimate is the sample value. So if you're testing proportions, then the point estimate is going to be a sample proportion. If you're testing the differences in proportions between two groups, then the point estimate is going to be the difference in sample proportions between the two groups. And so on. Alright, so a couple examples. Suppose a researcher claimed that 40% of babies are born on Monday. A sample of 1,000 mothers found that 3 in 14 mothers gave birth on Monday. So in this case, the claimed value is 40%, so that's my null value. And this is the proportion, so I need to figure out a proportion for the point estimate as well. In this case, we have a sample of 1,000 mothers found that 3 or 14 mothers gave birth on Monday. So my point estimate will be the proportion 3 and 14 out of 1,000. So 0.314. Now suppose pollsters wanted to see if men and women view candidates differently. A survey conducted last week found that 53% of men and 44% of women supported a candidate. For our class, you notice we're dealing with two different proportions here, so we're dealing with the difference in proportions. For our class, a difference in proportions is always going to be 0. That is, our null value is always going to be set for that there's no difference between the two groups. The point estimate is going to be the sample values, where we found 53% of men, 44% of women, so the difference in proportions for the sample is 9%. So again, the claimed value is always going to be 0. You can take that for granted for the entire quarter. The point estimate is going to be based on our samples, which is usually won't be 0.